If two sets of identical twins get married and each couple has a child, could the resulting children be identical? We believe that the resulting children would not be identical, but similar. Punnett squares tell you what alleles are likely to be expressed in the offspring. While Punnett squares can show twins look identical, it all depends on the dominant and recessive trait that the offspring will receive. In most cases, the dominant trait will win, but that won't always happen. For example, let's say the mother's genotype is lowercase b, and she has blue eyes. The father's genotype is capital B, lowercase b, and he has brown eyes. If we put this on a Punnett square, inside the square would be capital B, lowercase b, capital B, lowercase b, lowercase b, lowercase b, lowercase b, lowercase b. This would mean there's a 50% chance of getting blue eyes and a 50% chance of getting brown eyes. This could mean that one child could receive blue eyes while the other child could receive brown eyes, making them not identical. An embryo is created from one set of chromosomes from each parent. Twins are born when a single fertilized egg splits in two. Each embryo has the same genome and epigenome, but as they age, they become different. When twins are young, they stay similar to each other because they are in the same environment, but as they grow older, their environment starts to change. Signals from the environment activate the epigenetic tags. These epigenetic tags turn on or off certain genes. Environment changes that activate these epigenetic tags include diet, physical activity, exposure to toxins, and stress. This has a bigger impact to the viewer's question because the children do not have the same parent and aren't from the same fertilized egg. Not only that, but the identical twin parents also changed as they grew older due to the environment. Identical twins are also different by their DNA. It is believed that the DNA of identical twins is exactly the same. This has been proven false because during cell division, identical twins, still embryos, share all of their DNA. As they fully split and start developing, their DNA starts to change. Identical twins go through over 300 genetic mutations, also known as error copying. During their lifespan, over 100 genetic mutations could lead to over a trillion amount of genetic mutations. Along with genetic mutations, chemical factors activate or suppress gene expressions. This means that the chemical factors cause a change in the identical twins' body, changing the protein of each twin, making them not identical. When both sets of identical twins each have a child, it is possible that the resulting children would be identical. Similar to evidence number 1, there is a possibility that the child could have a 100% chance of getting blue eyes and a 100% chance of getting brown eyes. If the mother were to have blue eyes with the genotype of capital B, and the father were to have brown eyes with a genotype of lowercase b, when putting it into the Punnett square, you will get capital B, lowercase b, capital B, lowercase b, capital B, lowercase b, capital B, lowercase b. This would mean the child would have a 100% chance of having blue eyes. And vice versa. If the mother has a genotype of lowercase b, and the father has a genotype of capital B, the squares on the Punnett square would be capital B, lowercase b, capital B, lowercase b, capital B, lowercase b, capital B, lowercase b. This would mean that the child would have a 100% chance of having brown eyes. We can now, with a lot of research and evidence, safely say that identical twins are not identical.